Welcome to another episode of AI Frontiers. Today's topic is the robotics revolution. AI meets the physical world, synthesizing 31 papers from November 29, 2025. Buckle up for an exciting journey through 31 fresh robotics papers. The overview covers field basics, key themes, findings, methods, and spotlight papers. Discover AI-driven robots tackling disasters, ethics, and everyday tasks. Get ready for insights on future directions and how this synthesis was crafted. Let's explore how robotics is reshaping our world, one innovation at a time. Robotics blends AI with physical machines for sensing, thinking, and moving in real environments. It draws from computer science, engineering, and psychology to create adaptive bots. The field addresses global challenges like aging populations, disasters, and labor shortages. Key applications include factory automation, surgical assistance, disaster scouting, and agriculture. These papers highlight AI's role in making robotics reliable, intuitive, and impactful. A key theme is designing robots that collaborate ethically with humans. Lalwani et al. Use participatory design for productivity social robots aiding college students. This involves users early to address privacy and focus issues, like for ADHD support. It overlaps with detecting errors via bystander facial cues for natural safety. Such approaches ensure robots are intuitive, reducing risks in education and service tasks. Focus is placed on robots handling objects and navigating unpredictable environments. Xu et al. Enables sim-to-real transfer for humanoid door opening without retraining. This includes soft actuators for sensing object firmness in grasping, such as fragile items. Cycle-aware policies are developed for repetitive tasks, like assembly or surgery aids. The technical concept of sim-to-real transfer bridges virtual training to physical deployment. Randomizing simulations for realism. This theme extends to locomotion, such as legged robots on slopes using symmetry equivariant policies. UAVs and wildfires maintain paths despite unit losses through the Phi-Riemann algorithm. Constant time planning is applied for shelf picking and intercepting projectiles with noisy sensors. These efforts build robust movement, intersecting with manipulation for versatile robots. The technical concept of reinforcement learning trains actions via rewards, adapting to chaos through trial and error. Emphasis is placed on durability against adversity and integrated sensing for better awareness. Lapora et al. Reviewed tactile robotics, predicting e-skin for dexterous hands. Doppler LiDAR tracks fast obstacles, while UWB radar enables continuous detection. Fairness in multi-UAV planning balances workloads under uncertainty. These elements tie themes together for holistic, adaptive systems in real-world applications. Phi-Riemann achieves 99.9% uptime in drone swarms during wildfires. The H0 framework retains 81% performance for humanoid adaptation without retraining. Asynchronous inference in VLASH speeds up models by 2 times for tasks like ping pong. MDP decomposition slashes UAV computation time while maintaining optimality. Tactile sensing forecasts commercial booms in dexterous hands by 2025, as per Lapora et al. Reinforcement learning adapts actions via rewards, strong for locomotion but data intensive. Participatory design involves users for ethical robots, ensuring trust but time consuming. Vision language models fuse inputs for navigation, intuitive yet prone to hallucinations. Markov decision processes model planning in uncertainty, optimal but computationally heavy. Sim-to-real transfer uses randomized simulations for safe deployment, bridging gaps effectively. The paper by Lalwani et al., dated 2025, is titled Ethically Aware Participatory Design of a Productivity Social Robot for College Students. It was selected for its novelty in human-centered ethics, addressing real student needs like ADHD support. The objective is to design intuitive robots via user involvement to boost productivity ethically. Methods include interviews and workshops for features like empathetic reminders. Findings reveal preferences for non-intrusive coaching with significance in education and mental health. The paper by Lapora, dated 2025, is titled Tactile Robotics, Past and Future. It was chosen for its impactful historical roadmap, representing sensory integration trends. The objective is to map tactile evolution and forecast advancements like e-skins. Methods involve analysis of 150 reviews across generations, identifying challenges. Findings predict commercial ubiquity by 2025, with significance for prosthetics and beyond. The paper by Xu et al., dated 2025, is titled Opening the Sim-to-Real Door for Humanoid Pixel-to-Action Policy Transfer. It was selected for its transformative sim-to-real innovation, key to versatile humanoid deployment. The objective is to enable zero-shot transfer for tasks like door opening. Methods include GPU simulations with randomization and teacher-student distillation. Findings show it outperforms humans in speed, with significance for scalable logistics and homes. Deeper multi-agent systems with ethical fairness are anticipated for disaster response. Advanced simulations aim to close sim-to-real gaps, incorporating tactile feedback. Ethical frameworks must be standardized using participatory designs to prevent biases. Energy-efficient hardware, like photonic networks, supports scalable learning. The field moves toward human-AI symbiosis, with robots as everyday partners in industries. This synthesis was created using AI tools including GPT-Grok using model Grok 40709. TTS synthesis was handled using OpenAI and image generation using Google. While the synthesized content underwent review by a human expert, it is important to acknowledge that some oversights may still exist. All the references are provided for further verification. Subscribe to our YouTube channel for more thrilling AI and robotics insights. The title is AI Frontiers. Hit that subscribe button to stay updated on the latest breakthroughs. Share your thoughts and join the conversation. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.